In this problem, we're given several equations of different types, and for each one, we are to solve the equations for the variable x. In the first example, we have the reciprocal function set equal to 1/8. By inspection, you may note that if x were replaced with the number 8, you would get a true statement. So that means x equals 8 is the solution to this equation. Replacing x with 8 makes this a true statement. Therefore, x equals 8 is the solution. Another way to think of this problem would be that you could take both sides of the equation and raise to the -1 power, which essentially flips both fractions, in which case you'd have x over 1 is equal to 8 over 1, which gives you the answer x equals 8 once again. So this example was set up to help you with a slightly more complicated example where we have the reciprocal function set equal to 8/7. Much like I did in the last problem, we could raise both sides of the equation to the -1 power, which essentially reciprocates or flips fractions, and we'd get x over 1 is equal to 7 over 8. So x equals 7/8 would be the solution to this equation. In the next example, we are to solve x squared equals 9, which means we're supposed to find a number that when we multiply it by itself, we get the number 9. There's two ways I can think to do this. One way is that 3 times 3 is 9, but because our power is even and we're multiplying the number by itself an even number of times, you can use a negative number like -3 times -3 and also get 9. So whenever this power is even, you should always consider both positive numbers and negative numbers as possible solutions. So here we get x equals 3 as one of the answers and x equals -3 as a second answer. And I'd like to show you an alternative way of doing that problem. An alternative way of doing this problem would be to raise to a power such that the left side would simplify to be the letter x. Now, exponent rules say that whatever number I put here will get multiplied by 2. And since I'm looking for the solution to the equation to be x equals a number, that means I want the exponent to be a 1. So what I'll do here is I'll raise to the 1/2 power. By raising to the 1/2 power on both sides, I get the left-hand side to simplify down to be just x, because the exponent would be 2 times 1/2, which is just 1. And 9 to the 1/2 power is the same thing as the square root of 9, but you could type it in as 9 caret parentheses 1/2 on your calculator to see that you get 3. The only issue with this method, of course, is that only gives you a positive answer. You would have to know, since this is an even power, to consider the other possibility that x could be -3 as well. This problem, square root of x equals 8, can be done in a couple ways as well. One of the ways to think about it, that for the number under the radical to come out to be 8, it must be a repeated factor under the radical. In other words, if you had the square root of 8 times 8, that would come out as 8. So what that means is the number under the radical, called the radicand by the way, must be the number 64. 8 times 8 is 64. The square root of 64 is 8 because 64 can be written as 8 times 8. So the solution to this equation is simply that the number in the radical, indicated by x, must be 64. So x equals 64 is the solution to this equation, but I wanted to show you an alternative way of solving this using powers. Much like in the last example, we raised to a power so that the exponent rules would simplify this down to have an exponent of 1. I can do that here, provided that you know that the square root of x can be written as x to the 1/2. And to show that, you have to realize that since the exponent's not written, it must be a 1. And then since the index in the radical is not written, it must be a 2. So this is another way of writing square root of x, just including the details involved. Then there's an exponent rule that says you can write the left-hand side of the equation without using a radical if you divide the power here of 1 by the index of 2. In other words, square root of x can be written as x to the 1/2. Much like over here, I got the exponents to become a 1. By raising 2 to the 1/2 power, I'll do the same thing here, except since I already have a 1/2 power, I'll raise to a second power. And since I'm raising the left-hand side of the second power, I must do that to the right as well. The left-hand side, once again, would be simplified by multiplying the exponents 1/2 times 2, which is 1. So you get x to the first. And then 8 times 8 is 64. Same answer we got before. In this example, x cubed equals 64. We're looking for a number that when you multiply by itself 3 times, you get 64. So it turns out that 4 has that property that if you multiply it by itself, 4 times 4 times 4, you'd get 64. Therefore, the solution of this equation is x equals 4. Notice because we have an odd power, we need not consider the negative case, meaning that negative 4 times negative 4 times negative 4 will not be 64, because when you multiply a negative number by itself 3 times, the result has to be a negative number, and we're looking for a positive. Alternatively, you could solve this equation by raising to a power. Since the left-hand side has a power of 3, you could raise to the 1/3 power on both sides, and this would allow you to solve for x because the left-hand side simplifies down to be x to the first, because the exponent rules say that you multiply these exponents, and 3 times 1/3 is 1. So we get x is equal to 64 to the 1/3, which has the same meaning as before. We're looking for a number that when you multiply it by itself 3 times, you get 64. But in this form, it allows us to go to a calculator and type it in. 64, use the caret key, and then in parentheses, put 1/3. And the calculator confirms that my answer is x equals 4. In this example, you could argue how to find the answer in a very similar way than I solved this example. When the problem was square root of x equals 8, I argued that the only way that the number under the radical is going to come out to be an 8 would be if you had 8 times 8, meaning you have 2 factors of 8. And the reason there had to be 2 factors of 8 was because the index was a 2. In this example, we use the same argument, except for now the index is a 3, that the only way that the cube root of some number is going to come out to be 2 is if you had 3 copies of 2. So I just write that. I write 3 copies of 2 under the radical. And since I have 3 copies of 2, and this index is a 3, the cube root of that would come out to be 2. So I could write this as the cube root of 8, since 2 times 2 is 4, and then multiplying with a third 2, I get 8. This would read the cube root of 8 equals 2, meaning the number under the radical x is 8, and I get my solution of this equation is x equals 8. Alternatively, I could have written the equation as x to the 1/3 equals 2. This is just an exponent rule that allows you to get rid of radicals and write them this way instead. Since the power on the x was a 1, the exponent rule says you can write this without the radical if you take the power of 1 and divide by the index of 3. Once I do that, I realize that solving for x really means that you need the exponent on the x to be a 1. Since I want the exponent on the x to be a 1, I can put a 3 here to make that happen, since exponent rules say that we multiply these two numbers, and 3 times 1/3 is 1. But since I raised the left-hand side to the third power, I would have to raise the right-hand side of the third power as well. So my left-hand side will be x to the 1/3 times 3 is 1, and 2 cubed means 2 times 2 times 2, which comes out to be 8, and I get the same answer that I did before. My last example asks me to solve the absolute value of x equals 7. The definition of absolute value is the distance a number is from 0. So I included a real number line to help us visualize this problem. We're looking for a number so that its distance from 0 on the number line is 7. So we need to find all numbers whose distance from this point is 7. Well, clearly if I count 7 spaces to the right, you would end at x equals 7. So x equals 7 is one of the answers. There's also another answer because there's another number whose distance is 7 units from 0, and that would be if you counted 7 units to the left, which just gives you the same answer except in the negative direction. So if you counted 7 spaces to the left, since you're starting at 0, of course, you would end up at -7. So x equals -7 is the other solution to this equation. I hope all this made sense. And as always, best of luck.